In this video, I will show you how to run the code that I posted on the website. So first, click at the three dot button, and then from here you select the folder that you want MATLAB to consider as the current. So once you're done with that, then you open the files. From here you can click either using a toolbar or the menu bar. So now you can see all the examples open in my editor. So I will run through each. So let's look at the stock example. So first I run CLC and then clear all and then close all. So CLC clear the command window, and clear all meaning you delete all the variables in the workspace, and close all meaning that you want to close all the figures. And then you use the XLS read function to read this spreadsheet. Okay, the result is read into num. So then you will compute the rate of return. So let me illustrate this. So for example, num looks like this. Then you will take the matrix starting from the second row and then minus the matrix starting from the first row. So the difference is one row. So the difference here and there is just one row or one day. So doing this this way, you compute the rate of return for all the days. So then after taking the difference, you divide that by the stock price of the previous days, and you do this for all the days. And you may notice that because of the shift of one row, so ROR would have one row fewer. So in here you take the rows starting from the second row to the last row, and in there you take the rows starting from the first row to the row just before the last row, and then when you divide by the previous day closing prices, you take from the first row to the row just before the last row. and then later on you just compute the covariance and the correlation matrices and write the data using XLS write to Excel spreadsheets. So if you want to run this, just press F5 or click the button, or if you want to just run some selected lines, then you can select some lines and then press F9. So here I'm gonna press F9, I'm sorry, F5. So after running the code, you look at the workspace, and now you can see all the variables as well as the value, the size, mean and max values. So num contains the stock prices for 29, I think 29 stocks, and there are 960 rows or 960 days for stock prices. And after running it, if you look at the folder, then you see the result was written to stock result.xlsx. Okay, in the second example, and this is ucampus.m. So you see similar, actually the same commands for cleaning the environments. So first you read the image, and this is ucon.jpg into the memory using imread, and you want to resize the image a little bit, and then you want to reduce the intensity a little bit. So everywhere you see the value or the elements of the matrix is greater than 100, then you assign the value to just 100. So that is actually the upper bound. And then you read another image. This is campus.jpg into the memory. Okay, now you want to make them the same size. What I want to do here is actually like this. Campus is actually the photo of the campus, and then I want to display the other image, which is the UConn logo at the top left corner. In order to do this, first I will have to create a matrix of all zeros with the same size as the campus image. And then I name this UConn1. This is this line. With this line, I use the side function to measure the side of campus, and then use the zeros function to make the same or an array with the same size, and that is UConn1. And then I copy the logo, Yukon logo, to that, to the match the array that I have just created. And then if I display this image, then it would show me the logo at the top left corner. And you see in this area, you see black, just black here, just black. And now you can take the weighted sum of the campus image. This is the campus image, and the padded logo image with some width. So let's say like a 0.4 for the padded logo and 0.6 for the campus image. Then finally, when you display the image or the array, then you see the logo is like blended into the campus. Another version is a randomly weighted image, and it is Yukon 3, and we can see this by running the code. So I've just run the code, and you can see the padded logo is just like this. The logo is in the top left corner, and the rest is just black. And after blended with the campus image, what you see is this, and the logo is kind of blended into the campus image. And that is another version, randomly weighted sum of the two images. Now look at the third example. In this example, you read an image im01.jpg, and then you display the original image, and after that you want to play a little bit. You switch the color plane a little bit. So the third plane is then stored in the first plane. The second plane is kept the same, and the first plane is stored in the third plane, and you display it. And you also play a little bit more. You create a zero image or zero array with the same size as the original image or array, and then you store the third plane to the second to the first, and the first to the third, and then display the created image and see how it looks. And this is another version. Now you can see this is the original image, and this is the modified version, and that is another modified version, and that is another modified version. Is it interesting? Next is the multi-plot example, and this was explained in the lecture. So I just run this, and what you see is this. Here you have three sinusoidal curves with different colors. And finally, this is the multi-subplot example. And this example was explained in the lecture as well.